Okay, let's imagine that now we're dealing with either 2 or 3 dimensions, and we're looking for the center of mass. Well, for sake of ease, let's just think about 2 dimensions for right now. So imagine we've got some block here, another block there, and some block here, and let's call this 1 kilogram, 3 kilogram, and 5 kilogram. And what we know about these, well, we could construct a origin coordinate plane, and let's say that the 1 kilogram is at the point 0, 0. Let's say this is at the point 4, 0, and this is at the point 3, 2. Well, the center of mass has to deal with both the x position and the y position. So we're going to talk about the x center of mass and the y center of mass. And so to find the x center of mass, well, let's look at the x values. The 1 kilogram is at a position 0 away, plus the 3 kilogram, which is 4 units away, plus the 5 kilogram, which is 3 units away, and all over the total mass, which is 9. So the x position would be the sum of all that, which is 27 over 9. I didn't even mean to make it work out so nicely, which is at 3. And the y center of mass, well, same thing. My 1 kilogram times my y position, which is 0, plus my 3 kilogram times 0, plus my 5 kilogram times 2, all over the total mass, which is 9. And so this happens at 10 over 9. So therefore, my center of mass is at an x position of 3 and a y position of 10 over 9. So roughly right around here. So the way we can think about that is that our x center of mass, y center of mass, z center of mass equals the sum, well, 1 over the total mass, the sum of all the masses times the x positions. And the y would be 1 over the mass, the sum of all the masses times the y positions. And the z we could write as follows. Well, what we realize then is we could think about this in terms of a vector, where our center of mass, the vector center of mass, is just 1 over the total mass times the sum of mi, and then x, y, and z all together in terms of a vector. And this will come up later on in the next unit that we talk about, but this is a really helpful way for us to express center of mass in terms of a vector. Okay, so let's now check for understanding. So given this system, we've got at the origin a 5 kilogram block. Up here on the y-axis, we've got a 4 kilogram block at a height of 3. At the point 3, 3, we've got a 3 kilogram block, and at the point 5, 0, we've got another 3 kilogram block. So what we want to do is be able to find out where should that center of mass be. So somewhere in here, where is that center of mass? And here are your options. The first option is that the center of mass is at the point 3/5, 2/5. The next option is the point 8/5, 7/3. The next option is the point 3/7 over 8/5. And the next option is that you just have absolutely no idea. So why don't you this video is going to pause, take a minute to try to write this out, and then click on the right box and see how you did.